prove, using induction, that 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus up through 1 over n times n plus 1 is equal to n divided by n plus 1. So we're going to use induction to prove this is true. First thing we have to do is show that it's true for the trivial case, the n equals 1. Alright, so first let's show that s sub 1 is true. So the first case would be 1 over 1 times 2. Is this equal to, substituting n equals 1, 1 over 1 plus 1. The left-hand side evaluates as 1/2, right-hand side evaluates as 1/2, and they are equal. So we've shown that s sub 1 is true. So now, step 2. Assume true for s sub k. So therefore, that implies that 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus 1 over k times k plus 1 is equal to k divided by k plus 1. We're going to accept this as true, and now we have to show that s sub k implies that s sub k plus 1 is true. Alright, so now let's start with s. What would s sub k plus 1 be? So s sub k plus 1 would be 1 over 1 times 2 plus 1 over 2 times 3 plus 1 over 3 times 4 plus, and then we have the k term, 1 over k times k plus 1, and then we have the k plus first term, which would be 1 over k plus 1 times k plus 2. Now, I need to show, in the end, what I want is, I want s sub k plus 1, I want that to be equal to k plus 1 over k plus 1 plus 1. So notice how I've replaced the n's with k plus 1's. So that's my goal. That's where I'm headed. So now, I have to somehow use the fact, I have to use our assumption about s sub k. Well, notice that if I take these first k terms, that is s sub k. And by assumption, that is equal to k over k plus 1. So I have k over k plus 1 plus the k plus first term, 1 over k plus 1 by k plus 2. So I've got these two fractions, and in the end, remember, I'm trying to get a single term out of this, so let's combine these fractions, but to do that, remember, I have to have a common factor. So I'll rewrite the first fraction as k over k plus 1, and the common denominator here, I need a factor of k plus 2. So now, adding these fractions, I now have k squared plus 2k, and this, from the second numerator, I have plus 1 over k plus 1 by k plus 2. Notice that the numerator factors as k plus 1 times k plus 1, and the denominator is still k plus 1 by k plus 2. Removing the common factors between the numerator and denominator, I have that s sub k plus 1 is equal to k plus 1 over k plus 2. And notice that k plus 2 is k plus 1 plus 1. So we were able to show, using the assumption that s sub k is true, that then s sub k plus 1 follows. And so we've therefore proven by induction that this statement is true.